Okay, let's continue with question 9. In question 9, you have to find the radius of a circle whose central angle, the radius of a circle whose central angle, whose one of the central angle intercept an arc of length 12 pi centimeter, and the angle is 15 degree. Okay, so you have a circle right here. You have a central angle, means the vertex is at the center. The angle is 15 degree, and it intercepts an arc of length 12 pi centimeter. Oops, 12 pi centimeter, and you have to find the radius. Okay, so the relation between the radius, the angle, and the arc length is S equals R theta. Okay, so if you know S and theta, it's easy to get R. R would be S divided by theta. But you got to be careful when you use this formula. You can only use it when the angle is in radian. This formula is actually the defining formula for radian angle, okay, for the unit radian. So what I have to do right here, the first thing I have to do is turn 15 degree into radian. So 15 times, so it's not 180 over pi, it's pi divided by 180. Okay, so let me divide by, let me not put a degree sign right here. Let me divide by 3, so that's 5, and this is 60. And now let's divide by 5, so it's 1, and that's 12. So the angle is actually pi over 12 radian. We don't have to write rad. If you don't put the unit, it means radian. So now let's just apply the formula. R is pi over 12. Actually, that's where my main fraction bar is going. Pi divided by 12 divided by, no, sorry, I'll get it right, that's what I'm dividing by. Okay, so, sorry, length, it's 12 pi divided by pi over 12, so this is 12 pi over 1 times 12 over pi, and so it is 144. 144 what? Same unit as for the arc length, centimeter. Okay, so it's not this one, it's not this one, it's not this one, it's, is it this one? Well, you have to change right here the unit, centimeters, decimeters, meter, right? 1.44 meters. So indeed, it is this one. Okay? Alright, question 10. Question 10, they're asking us to find cotangent theta minus cosecant theta. Gotta be careful. Theta is right here. Cotangent, well, tan is opposite over adjacent, so cotangent is adjacent over opposite. Cosecant is hypotenuse over opposite. Okay, so the cotangent minus the cosecant would be, so cotangent adjacent 5, opposite 12, minus hypotenuse 13, opposite 12. 5 minus 13, negative 8 over 12, divided by 4, negative 2 over 3. Negative 2 over 3, so that is going to be D. Alright, let's move on to 10. Okay, a 16 meter long, sorry. A bit tired. A ladder 16 meter long just reaches the top of a building and its foot make a 76-degree angle with the ground. Alright, so let's draw the building here. Here's the ground. Here's the building. And the top of the ladder reaches the top of the building, right? Or rather, the ladder reaches the top of the building, just reaches, so that means the top. See you! Sorry, these were my advisee leaving. Okay, so what do we have? Angle with the ground, ladder and the ground, that means right here, 76 degree. The ladder is 16 meter long, and the question is about the height of the building. So which equation represent the height of the building? Alright, so let's see. Obviously when you look at the angles, you are dealing with 14, so 14 goes right here, right, complementary with 16. So let's see, is the cosine of 14 degree, that's adjacent over hypotenuse. Yep, that's the one, right? Okay, adjacent over hypotenuse, so that works. Let's look at the others. Well, that would not be working. Tangent 14. So let's see, this side right here would be measuring 16 square minus h square, but the tangent wouldn't be h over that, it would be this over that, so this is false. And the secant of 76, we don't play with h for the secant, so actually it was the first one I found, right? Here we go, A. All right, okay, question 12. So this point is on the terminal side of the angle alpha. What is the measure of alpha? Okay, well, you know, you really have to recognize the point right here. I know these two values are outputs of cosine and sine, and the angle is like pi over 4, or, you know, 45 degree. I mean, I'm dealing with two outputs of cosine and sine, right? They are also on the unit circle, right? These two values are on the unit circle, being output of cosine and sine. So I'm talking about any of the four angles right here, right? I'm talking about any of the four angles right here. So now let's pay attention to the sign. Negative and negative. Therefore, actually, let's keep the red. Therefore, negative and negative. I'm talking about this angle right here. I'm talking about this angle right there. All right. And so the question is, well, how do you read that? Well, how many 45? So 1, 2, 3, 4, 5, 45. Well, actually, this is 180. 180 and 45, 135. No, sorry, 180 and 45, 225. Okay, so this is 225 degree, which I don't see here. It's not 135. 135 is actually right here. But it is negative 135. Here we go, negative 135 degree. It's B. Okay. 315 would actually be this one right here. Here, let me write them quickly for you. This is 45, 135, this is 90, 0, this is 180, 270. Yeah, that's it. Okay. All right. I think I'm almost done with the first section here. Question 13. The expression ln of 10. So what is this all about? Well, when you look at that, obviously there's a rewriting of 10 right here, right? I mean, I don't see any 10 right there. So what do you know about 10? If you were to rewrite it differently, there's only one way to do that, right? 10x is sine x over cosine x, right? So ln of 10, this is the log of a ln of 10x. This is a log of a ratio. We are already seen this formula in this first questions. The log of a ratio is a difference of log sine x minus ln of cosine x. And actually, yeah, I should have written it like that. That's kind of funky and interesting. Plus, you know, this can go at the power right here, right? Ln of cos x minus 1. Be careful, this is not the inverse function of cosine, this is a reciprocal. So it's ln of sine x plus ln of secant x. I should have proposed my answer to be that. It would have been one step further than what I gave you. I gave you this one right here, b. Okay? Okay. Another trick question, and the last one is going to be trick 2, right? Yeah. Oh, the last one is so easy. Here, let's do 15 before. Ah, look at all the me marks right there. Okay. When I write here, my computer takes part of my writing and just display it somewhere else. Here we go. All right. Okay. All right. So as I said, let's do the last one. It's going to be easier. Or rather faster. And then we'll do 14. The secant is positive. Well, secant is r over x. So that means x is positive, okay? The cotan is negative. Now, cotan is x over y, and that's negative. Now, x is positive, so that means that y is negative, right? If you want x over y to be negative and x is positive, then that means this one has to be negative. So x positive, y negative, x positive, y negative, you are in Q4. Alright, so now let's do this one. Actually, I don't think it's going to be too difficult. Let's see. You remember what I've been telling you about these, right? You got to turn everything into sine and cosine. So I'm not going to touch that. And this right here is 1 minus 1 over sine x. Okay, so you know what to do here. We've done it. If you don't remember, just watch the video, okay? Sine x, and here we have sine x. So let's see. I'm not inclined to expand the top. Maybe I will have to, okay, but right now, yeah, something is gonna happen. I can smell it. Times sine x over, so sine x minus 1 right here, right? Sine x minus 1. And how do you simplify 1 minus sine x and sine x minus 1? How do you simplify a minus b over b minus a? These two quantities are just called opposite, right? And to simplify two opposite, it's just negative 1. That's what you have. So I'm going to cancel this with that, and I'll find negative 1. So it's negative sine x. And negative sine x is c. And with this, we're closing the first part.